Okay, so this is a series of lectures about experimental design. The reading is chapter 8 of Cosby and Bates, although I think this is much beyond the text, although it does follow that structure. So the first thing is to consider the logic of inference. What are we trying to do here? And so to understand all of this comes back to random assignment. So if you recall, when we're talking about how we get subjects, we have all sorts of different ways of doing selection. And we talked about stratified random sampling and clustered randomized sample or simple random sample. The problem is that all of those are either expensive or in the case of simple random sampling, almost impossible. And most often we end up using convenience sampling. Even your studies where you are asking 100 people to contribute to your study, even though you're randomly selecting from your Facebook pages, it's still a biased sample because they're still your friends. And so no matter what, we are likely facing a biased sample when we're bringing them into the lab. So to resolve that, random assignment takes that sample, whatever it may be, and then randomly distributes those individuals in a condition so that whatever bias came into that sample is distributed randomly between the groups. And therefore, differences between the groups are no longer due to the bias of the sample, but now hopefully due to whatever you're manipulating. So if you keep everything exactly the same, except for the manipulation or the factor, or whatever it is, the independent variable, then any outcomes must be due to the factor and not due to some other criteria. So this is a little bit of an aside, but I think to connect the course, the statistics half of this course, the design half of this course, to recognize that we have inferential statistics tend to be difference-based statistics. So z-test, one sample t-test, paired samples t-test, independent t-test, ANOVA, we haven't learned that one yet, but these are all different statistics. And they come from certain designs. And they give you certain outcomes. So if you recall that a z-test is how is my sample different from the population, you get that from a survey. The same with a one sample t. Remember, the only difference there is we don't know the population well enough to use the population characteristics in the statistic. So in both of these cases, you're really getting data about a sample and then comparing it to the population, not an experimental circumstance. A paired T is a pre-post test situation, a repeated design. You have somebody, you measure them before and after, and now you've got a paired T or a repeated T or within T. Independent T, you've got two different people, the between subjects design. They're not the same. And then ANOVA, which we'll learn about in the fall, is a design where you have more than two groups, and we can have those as either repeated or between. Now, in contrast to this collection of difference-based statistics, there are inference or relationship-based statistics that are not for inference. So correlation measures in a descriptive way the relationship between X and Y. Simple regression takes that correlation, the relationship between X and Y, and plots it in a line so you can estimate Y if you know somebody's X score, given that there's a priorly established correlation. And then finally, if you have a whole bunch of predictors, then multiple regression, you're predicting Y of all of the relationships combined. And don't worry, they come in the future. The point here is that they're both existing and that relationship statistics can do different statistics. So there will be the case where I'll do an experiment and then use a regression because I manipulated something in such a way that I want to take advantage of the improved power that you get from regression. All right? Different statistics are used to determine if something is statistically significant. So, if I'm describing a correlation, if I want to know if that correlation is statistically significant, I use a different statistic, in this case a one sample t, to determine if the R is different than 0. I understand that this is all very confusing, but correlation and regression are coming next week, and I'm trying to help you see the connections between the z-test to regression through t-tests, and to understand that they're trying to do different things even though they use the same math. And I'll make that have more sense next week. just ponder on those issues. So in summary for this video, random assignment, we evenly distribute that bias across conditions. And there are two classes of statistics. We have difference-based statistics, z-test, one sample t, paired t, independent t, ANOVA. And then there are relationship statistics, correlation and regression. Depending on what you do, you're going to use a certain statistic. Experiments primarily evoke difference statistics. Okay, I'll see you in the next video.